Hey everybody, so today just wanted to kind of demonstrate a hardware abstraction layer in LabVIEW using object-oriented programming. So in our previous kind of object-oriented primer, we briefly mentioned this, wanted to kind of give an actual demonstration of what this can look like. And this kind of goes one layer deep. You can definitely go even deeper than this. But yeah, just to demonstrate, so I have this DMM, and it's probably easiest to show it with the class hierarchy. So I have my LabVIEW object. I've created a DMM class that is a child of the LabVIEW object. And I'll show you what this looks like. This is basically just an empty class. So it has methods, but the methods don't actually do anything. And then I've created specific implementations of different models of DMM that are children of the DMM class. So I've got a BK, a Fluke 45, Fluke 8808, and a Siglent SDM. So these are children of the parent class. So yeah, our DMM class, being the parent, has these functions that are empty, right? There's actually no functionality in there. They don't do anything. If you go to any of the children, you get the specific implementation, right? So this is now using the Fluke 45 instrument drivers to close out that device. Same thing goes for if I'm configuring. I have the actual, commands that are specific to the specific model. Now let's look at just what these look like side by side. So I've dropped each of the classes I've created here just so you can see. So here's our parent class DMM. Each one has an open config read close. So they're just configuring the multimeter to measure resistance, and then they're reading the resistance and then closing. So there's specific implementations. You can see there's different classes for the different models. Now let's look at what this could look like in your LabVIEW code. So I have this simple HAL example. We're going to look at some maybe better ways to do this. But the first way would be just having, so I've dropped all the parent functions. So this is the DMM class. And then I'm loading in the appropriate child class based off of what's selected here. So I just have a case structure, and then from there I'm just loading in the child class, and then it will automatically overwrite these functions with whatever I've selected, which is kind of cool. For example, if I click this open, it automatically knows that this can be overwritten, so I get an option of, hey, what do I want to open? So there's the DMM class, which shows as a parent. It's indented a little further to the left, and the children are down here. So I can see here what my parent class looks like. There's not actually anything happening in this. It's just storing some data. But if I go to the BK, I have a different implementation, right? If I go to the Fluke 45, I have a different implementation. If I go to the Fluke 8808, I have a different implementation. On and on and on. And the same thing goes for all these other functions. They all look the same. Or I've got different read functions in there. So this is one way to do a simple hardware abstraction layer. The downside to doing things like this is if I decide to create another new class, so if I maybe buy a new multimeter and I build a new child class for it, I also need to go update this case structure and then drop it down in here, which isn't that complicated, but there are some better ways to do that. So let's look at two other ways. So another thing we can do is we can load classes by name. So I have an example here where we are using this function called get LabVIEW class default value by name. So we basically pass in a string with the name of the LabVIEW class, and it returns a generic LabVIEW object, but that object specifically carries our specific class, which is kind of abstract. So this always is going to return just LabVIEW object, and then you can use the to more specific class function to actually cast it to your specific class. Just because a wire looks like this doesn't mean that's necessarily the class that it's carrying. It's kind of interesting. Any wire can carry either a parent or a child class on the wire. So because LabVIEW object is the ultimate parent, right? And our DMM is a child of that. It's able to carry the DMM class. We can basically cast that to the DMM class. But then even if we have a child implementation here, that will be actually passed along this parent class into these other functions. So, and it doesn't have to be loaded from a drop-down list like this. We could be dynamically creating this string from different things. One requirement though is this class does have to be stored in memory for this to work. So the class has to be loaded into memory for you to load it by name. Another thing you can do is load it from file. So this is going to be typically how classes are used as plugins. You'll hear about the factory pattern. This is essentially the factory pattern in that we basically can take the path to a class, load it using this get LabVIEW class default value, and just like the other function, this is going to return a generic LabVIEW object, and we can use the to more specific class to actually cast that to our specific class type. And so even though this wire is the DMM LV class wire, it can actually carry its own children classes on there. So if we're working with like a Fluke 45, this will look like the parent class, but when we get to these functions, it will actually call the Fluke 45 specific stuff. So this is a good way to create a hardware abstraction layer. You can create your children classes that act as plugins, and you can actually include these plugins. For example, if you're building an exe, you can build your exe like this, and then I can create those plugins, and without actually changing my exe, I can create new plugins to be used in the exe, which is kind of cool. That way I can add new functionality to a program without actually changing the program itself, just adding new classes that can be loaded dynamically. So, but yeah, that's essentially a hardware abstraction layer in LabVIEW. And this format specifically is referred to as the factory pattern. So this is, when you're thinking of object-oriented design patterns, this is the most common one you will hear about, is just a factory pattern. And it's just a simple way to load children kind of on the fly that have their own specific implementation. So thank you guys for tuning in today. I hope that was helpful. I will be back with some more training on object-oriented programming in LabVIEW shortly. Thank you.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.